We're going to work in this session on an old school drive system, talk about some of the issues. We're going to start with opening our code up. Before we get into that, I'd like to clean up some code a little bit and reorganize things so that it's a little easier to understand. I'm going to take all the PWM type devices and put them in one group, and the pneumatic devices and put them into their own little section, and then group our digital and analog sensors together right here, and that will make navigation a little bit easier. These two lines here, we're going to use these for this exercise to represent a left and right side drive motor for a robot base. They are PWM driven Victor SPs. It could also be a Spark or some other PWM motor controller that you have. PWM is a one-directional communication. We're going to be programming and talking like the devices are actually connected. If they're not connected to the Robo-Rio, don't worry about it. It was not going to hurt this exercise. I'm also going to create another variable here, a double, a real number. I'm going to call it sine, and just initialize it to 1.0. We'll see what we're going to do with that in just a moment. The next thing I'd like to do on the housekeeping is just put some comments in to help us browse the code a little easier. If you have 2 slashes in the beginning of a line, that makes the line a comment, but I'm going to have 10 slashes here. Just want to copy that and paste it as 20, 30, 40, 50, 60, 70, 80. And all I'm trying to do is just create a visual break between the procedures. Helps us kind of peruse the code a little easier. So that kind of helps separate things out visually. So let's go back up to, we're going to talk about teleop periodic. There's nothing we really have to do here. Our Xbox controller is in place. We're reading the Y values off the joysticks here and here. And it turns out we're already setting the speeds on the motors with the set commands. So we have the gets and the sets. What we're going to do is we're going to jump in this area here between the get and the set and modify the values of left Y and right Y that are conditioned on other requirements. To make this go a little faster, I'm just going to copy and paste some code that I've already written. I'll just paste it into place and then we'll go through it so we can understand what it's doing. So this is the block of code I just pasted in right here. This is right above the motor sets, and it's after the Xbox gets. First thing we're going to do is we're going to set a speed limit or maximum power of the left and right motors. The values coming off the Xbox controller and the values going into the speed controllers, they vary from -1 to +1. It's a real number. It's not an integer. So we're on the number line from -1 to 1. What we're going to do is I'm just arbitrarily picking 50% power. So if we're at 50% power, we say if we're less than -0.5, just make it -0.5. If we're greater than 0.5, make it 0.5. Do the same thing for the right side. So we've clamped this. We've constrained it to a narrower range on the number line. That sets the maximum speeds of 0.5 in the plus and minus directions. One phenomenon that you see here, if you look here to the left, you'll see these dead band or these values here when the joystick is sort of idling. This is sort of typical, but it's not 0. This number here is because I've got a defective left joystick, semi-defective. Just ignoring this one here, just look at the right one. We want this to be 0. When it's a small number, make it 0. That's the way we do that. So we take the absolute value of the number, because it could be positive or negative. And if it's less than something small, I picked 0.1, just make it 0. Same from the right joystick. If it's less than 0.1, just make it 0. This is a floating point absolute value. If you get rid of the f, it becomes an integer absolute value. If we're to use this function, the only result you'd get from it would be -1, 0, or 1, which would not be very helpful, especially after we've already clamped the values here. So we'd never get anything but 1. But with floating point absolute values, we can properly set the deadband. If you take, since the numbers go from -1 to 1, if you were to take a number like, say 1/2 and square it, 1/2 times 1/2, that's 1/4. If you had 1/4 and squared it, 1/4 times 1/4 is 1/8. If you were to plot this out, plot out a chart, all the values from -1 to 1 on the x and y axis, you'd see an exponential curve. So what we're going to do here is create something called an exponential throttle. Oftentimes you'll see students create a robot that can drive it well at high speed, not so well at low speed. If you create the exponential throttle, what it does is the closer you get to 0, the more fine-grained control that you will have. And the way you do this is by going from a linear transfer function to an exponential one. And that's easy to do. So the first thing we do is we look at the y value and see if it's negative. If it's negative, we're going to set this sign variable to -1.0. If it's positive, we're going to set it to 1. The reason why is we're going to take the y value and square it. This value times this value, if they're negative, this will become positive. But we have to preserve the sign, so we just multiply it by -1, and then we have this number squared, and the sign is preserved. Do the same thing for the right side, and then that way you have an exponential function. So we have speed limits, we have taken care of our deadband, we have an exponential throttle right here, and then we set our motors. That in a nutshell is how you do old school drivetrains with 2 motors. If you had 4 motors, 2 left motors and 2 right motors, you would also set those values accordingly. Just for fun, let's compile it and deploy it. I have built and deployed the project. Let's go to the driver station and click Enable, and go to the shuffleboard and click in the space here and hit Control-N to refresh the shuffleboard. Some of our values went away, but here's the right the right Y. And here is the left Y. And it's doing what it needs to do, even with a semi-faulty joystick. That's how you do old school drivetrains.